Good afternoon, everyone. Thank you for attending my presentation. I'm Keitaro OHNO. As a member of GSI, I'm responsible for the product operation of the Japanese IGS Analysis Center, JGX. In this presentation, we would like to introduce the overview of the operation and prospects. Doesn't work.
Try again.
Okay.
So you can't see it here. Can you see it here?
Yes. No, I can't.
Yeah. Sorry about that.
Okay. As an introduction, let me show you the overview of Japanese IGS Analysis Center project. JGX works based on the collaboration between GSI and JAXA. We have been one of IGS Analysis Centers since last December. GSI has operated 1,300 GNSS core network in Japan for over 25 years. And including GNSS data analysis, we have managed Japanese reference frame system. On the other hand, JAXA has developed precise orbit determination software named MADOCA for many years. And JAXA has the technology and was involved in QGSS payload development. By combining the strengths of both institutions, feature operation and software improvement, we can ensure long-term operational and development capabilities. Our objective is to contribute to global reference frame and IGS activities. And in addition, by generating IGS-compliant products, we aim to maintain and improve realization of Japanese geophysical reference system and Japanese POD software. We can contribute following 3 ways: providing independent multi-GNSS products from other ACs via our original software, MADOCA, developed by JAXA, improving POD quality for QGSS as a Japanese IGS Analysis Center, and providing a stable supply of products through years of GNSS core's operational experience by GSI. This is a JGX operational products list. Our operational products launched in July last year and have been incorporated into IGS combination process since last December. Among the post-processing products, the final and rapid products have been provided to IGS Data Center, CDDIS, and IGN. Our products have the satellite of GPS, GLONASS, and Galileo, and final and rapid products have been provided on a weekly and daily basis. And the ultra-rapid product is currently under development. We are having problems with the accuracy of the prediction part, so we are working to improve it for future submissions. Next, let me show you the quality of JGX products. From this slide, we will show you the quality evaluation of our final products. Firstly, it is the result of satellite audits. This figure shows the 3D RMS for the period since the start of the provision to the IGS. From the top are the results for GPS, GLONASS, and Galileo. The references are the IGS final for GPS and GLONASS, and ESA final for Galileo, respectively. Each color indicates each analysis center looking at the blue line, which is our JGX product. Each satellite orbit quality is moderate to other ACs, like this figure. Secondly, this is a quality evaluation of GPS satellite clock error based on the IGS final product. Looking at the upper row of standard deviation, the variation for each satellite is comparable. Looking at the lower row of RMSE, the value was large in the early period. it indicates that there were satellite-specific offset. We revised DCD file and signal processing in September, and then the satellite-specific offset problem was resolved, like this figure. Since the product is currently not included in the IGS combination for stability reasons, the challenge is that if there is a lack of valid data in clock reference stations, our product will be not good. So we are working to improve stability by reviewing how we set our clock reference. Thirdly, this is a quality evaluation of the station's position. This figure shows RNSE for 3 components based on the IGS combined product. Since we had offset about 2 mm for the UD component in the early period, we applied a second-order ionosphere model last November. And then the quality has been moderate for each component. Finally, this is an evaluation of the Earth orientation parameters. This figure indicates simple differences with the IGS final product. From the top, X and Y components of the rotation axis and the length of day. These are also consistent with IGS results for the period since the start of provision to the IGS. As a next topic, I would like to introduce a precise orbit determination for Japanese satellite QZSS. Currently, QZSS has 4 satellites. The additional 3 satellites are planned to be launched for the 7 satellite constellations. In addition, the Cabinet Office is planning the concept study for the 11 satellite constellation. The constellation will provide independent PNT capabilities in the region, as well as further augmentation of GPS and other GNSS. The MADOCA software also supports QZSS, and we have been developing the technology in parallel with the generation of our operational products. As the organization in charge of development, JAXA has been participating in the NGEX project and providing NGEX products. This slide shows the status of recent efforts regarding QZSS. To improve the precise orbit determination for QZSS, JAXA has adapted the following analytical force models: solar and earth radiation pressure based on both-wing model, and thermal radiation pressure for QZSS satellite, and considering satellite antenna thrust effect and shadow model for QZS3 reflector. The last topic was reported by Akiyama et al. Today's morning meeting. GSI also calculates test products, including QZSS, to evaluate the impact of JAXA's these improvements on QZSS or orbit determination. This figure is a comparison of each HC's product based on satellite weather range SLR. Each row indicates each of the 4 QZSS satellites. The top 3 figures show satellites in IGSO orbit, and the bottom figure shows satellite in geo orbit. Our products are shown in green and pink dots. Compared with the RMS values listed to the right, here, the consistency is at or above the same level compared to other ACs. The geostationary orbit satellite has a larger deviation due to estimation difficulties. The difference between green and pink dots is results before and after the adoption of model improvements introduced on the previous slide, respectively. The updated test product is more consistent with SLR. The variation in all 4 satellites is reduced compared to the previous test products. We will continuously work to develop QZSS POD technology. At the end of this presentation, I would like to inform you about the JGX products providing service. Our JGX operational products are also available at our original website. This web page was established to promote the use of our JGX products as a high-precision infrastructure in Japan and overseas. At the website, we provide not only operational products, but also GSI's multi-GNSS test products with registration. Let me summarize my talk. JGX has begun contributing as an IGS analysis center since last year. Our short-term goals are developing ultra-rapid products for GPS, GLONASS, and Galileo, and further improvement of the precise orbit determination for QZSS. And our middle and long-term goals are maintaining and updating stable product quality and supporting realization of a global reference frame. Thank you for your continued cooperation in our activity.